Hello students. Today in this lesson we will solve some simple problems based on vector addition, and for that we will use parallelogram law of vector addition, which we did in previous class. I hope you remember the expressions for magnitude and direction of resultant vector. But before doing that, first we will see how a vector is resolved into rectangular components. Here you can see the position vector OA in xy plane, which is also represented by vector R. The projection of point A on two axes are x and y, which are called the components of vector R. Hence, vector R is equal to Ix plus Jy. In 3 dimension, this vector R is equal to Ix plus Jy plus Kz. You already know the unit vectors I, j, k along the 3 axes x, y and z. In the expression, vector R is equal to Ix plus Jy. X and y represent the magnitude of the components, and I and j give direction. The magnitude of vector R is given by under root x square plus y square. You can see in right angled triangle OAB, R square is equal to x square plus y square. In 3 dimensions, R is equal to under root x square plus y square plus z square. So, we can resolve any vector into its mutually perpendicular components, like force is given by vector F is equal to I Fx plus j Fy in 2 dimensions, and it is I Fx plus j Fy plus k Fz in 3 dimensions. And we can calculate the magnitude of the vector if the magnitude of its components are known. This will be more clear by solving a simple problem. The question is, a force is represented by vector F is equal to 2I plus 3j plus 6k Newton. What is the magnitude of the force? The solution is, as the magnitude of force is equal to under root fx square plus fy square plus fz square. So, substituting the values of fx, fy and fz, it is equal to under root 2 square plus 3 square plus 6 square, and solving it we get under root 49, which is equal to 7 Newton. So, magnitude of force is 7 Newton. Let us do some more problems. Next question is, two vectors are given as vector A is equal to 3I plus 9j minus 6k, and vector B is equal to 8I minus 4j plus 8k. Find the magnitude of vector A plus vector B. Here, vector A and vector B are expressed in terms of their components. So, their addition means addition of their respective components. So, vector A plus vector B is equal to 3I plus 8I plus 9j minus 4j plus minus 6k plus 8k, which comes out equal to 11I plus 5j plus 2k. The magnitude of vector A plus B is therefore equal to under root 11 square plus 5 square plus 2 square, which is equal to under root 150. Another question is, determine the vector which, when added to the resultant of vector A, is equal to 3I minus 5j plus 7k, and vector B is equal to 2I plus 4j minus 3k, gives unit vector along y direction. Here sum of vectors a and b is vector r, which is equal to 3i plus 2i plus minus 5j plus 4j plus 7k minus 3k, or r is equal to 5i minus j plus 4k. The unit vector along y-axis is j. Therefore, the required vector p can be expressed as p plus r is equal to j, or p is equal to j minus r. And finally, p comes out equal to minus 5i plus 2j minus 4k. So, when vector p is added to sum of a and b, the unit vector j is obtained. I hope solving these problems, the concept of vector components is now clear. Next, we will solve some problems of vector addition using parallelogram law of vector addition. Let us begin with the question number 1. Two forces of 3 Newton and 4 Newton are at an angle of 60 degree. Find their resultant. If the forces are at right angle to each other, then also find their resultant. Here the two forces are F1 is equal to 3 Newton, F2 is equal to 4 Newton, and angle between them, theta, is equal to 60 degree. The resultant of two forces is equal to under root F1 square plus F2 square plus 2 F1 F2 cos theta. Substituting the values, magnitude of resultant force is equal to under root 3 square plus 4 square plus 2 into 3 into 4 cos 60 degree, which comes out equal to under root 37, which is equal to 6.08 Newton. And direction of force is given by tan alpha is equal to F2 sin theta by F1 plus F2 cos theta, which is equal to 4 into root 3 by 2 divided by 3 plus 4 into half, the value of which comes out equal to 0.69. When theta is 90 degree, then value of f is equal to under root 9 plus 16, which is equal to 5 Newton, and tan alpha is equal to 4 by 3, which comes out equal to 1.33. Next question is, the resultant of two equal forces acting at right angles to each other is 1414 Newton. Find the magnitude of each force. Here R is equal to 1414 Newton, theta is equal to 90 degree, and P is equal to Q. Therefore, R, which is equal to under root P square plus Q square, gives 1414 is equal to under root 2P square, or root 2P is equal to 1414. So that P is equal to 1414 divided by root 2, which is equal to 1414 by 1.414 equal to 1000. Hence, P is equal to Q is equal to 1000 Newton. Another question is, the sum of magnitudes of two forces acting at a point is 18 Newton, and the magnitude of the resultant is 12 Newton. If the resultant is at 90 degree with the small force, what are the magnitude of forces? Here P plus Q is equal to 18 Newton, R is equal to 12 Newton, and alpha is equal to 90 degree. As R square is equal to Q square minus P square, which is equal to Q plus P into Q minus P, or R square is equal to 18 into Q minus P. Therefore, Q minus P is equal to 12 square by 18, which is equal to 144 by 18, and that gives q minus p is equal to 8. Now q plus p is equal to 18 and q minus p is equal to 8. Therefore, we get q is equal to 13 Newton and p is equal to 5 Newton. One more question is, the angle between two vectors of equal magnitude is 120 degree. Prove that the magnitude of their resultant is equal to either of them. As p is equal to q and theta is equal to 120 degree. Therefore, r is equal to under root p square plus 2p into p into minus half, as cos 120 degree is equal to minus half. So, r is equal to under root 2p square minus p square is equal to under root p square, and hence r is equal to p, which was asked to prove. The parallelogram law of vector addition is also used to solve problems of relative velocity, which we will do in next class. See you then.